Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 128, longest consecutive sequence. For this problem, we're given an unsorted array of integers called nums, and we want to return the length of the longest consecutive element sequence. And we have to ensure that the algorithm that we develop is going to run in big O of n time. So what is meant by the longest consecutive element sequence? Well, if we write out the nums array in sorted order, we will get 1, 2, 3, 4, 100, and 200. And the reason I left a gap between these two sequences is because they are not consecutive. So we can see that we have one sequence here that is consecutive, we have another consecutive sequence, and then we have another consecutive sequence. And if we want to determine which is the longest, well, we just take the length of the sequences and then we just total them up and find the largest one. So we have a length of 4, a length of 1, and a length of 1. So clearly the longest consecutive element sequence is a length of 4, and this is what we're going to return at the end of the algorithm. So how can we actually get the longest consecutive element sequence? The way we did it was to find a sorted order for the nums array. But we know that sorting the array is going to have a worst case time complexity of big O of n log n. And this is definitely greater than big O of n. So this is not a valid approach to this problem. So we can imagine these numbers on some sort of number line. So we can have, let's say, the number line here, and each of these are in a sort of sequence depending on where they are in the number line. So can we figure out what separates the number line? So this gap right here. Well, we can see that the start of a sequence has no preceding value. And I mean, that's pretty obvious. If we have something like 4, well, this has a preceding consecutive value 3. But if we look at 100, there is no 99. And this is exactly the definition that we need. So can we use this fact to develop the algorithm? Well, yes, we can. And the first step is to take this nums array and convert it into a set. And the reason we do this is because we know that lookup time in a set is going to be, on average, big O of 1. Then what we can do is we can go through each of the elements in the nums set that we have created and check to see if it defines a new subsequence. More precisely, that means there is no nums minus 1 in the set, and we can do this operation in big O of 1 time as opposed to big O of n if it were a list. So let's say we start at the first element in the nums. Well, it is 100, so we check to see if nums minus 1 is in the set, and if it's not, that means we have a new sequence. Well, 100 minus 1 is 99, so we check to see if this value is in the nums set. It's clearly not, so we know that there is a new sequence that's defined by 100. Then from 100, we look to see if we can find elements larger than 100 and such that it maintains a consecutive order. So More precisely, that means we're looking for 101. But 101 is not in the num set, so we just stop the subsequence at 100. And currently we have a largest length of 1. Then we take a look at the next element in nums, so this is 4, and 4 is preceded by a nums minus 1. So clearly we cannot define a new sequence starting with 4, so we move on. We check 200, and 200 has no preceding value, so 199 is not in the num set, so we can say that 200 defines a sequence. Then we check to see if 201 is in nums, and it's not, so 201 stops the sequence, and we still have a longest length of 1. Then we take a look at 1, and 1 has no value prior to it. If it did, that means 0 would have been in nums, but it's not. So we can define a sequence starting with 1. Then we check to see if 2 is in the nums set, and it is. Then we check to see if 3 is in the nums set, and it is. Then we check to see if 4 is in the nums set, and it is. And then we check to see if 5 is in the num set, but it's not. So we stop here and we go to the next element in the num set. Then we check at 3, and again there's a value before 3, so we just don't do anything. And then we check 2, and there is a value before 2, so we don't do anything. And clearly the longest sequence that we found was this one with a length of 4. So this is what we return as was required by the problem. And we can see that this time complexity is just going to be big O of n, since we're using the big O of 1 lookup time, and we just keep going until we stop at a value that is not in the num set. So with that being said, we can go ahead and write the code on LeetCode. Okay, we're on LeetCode and we can start writing the algorithm that solves this problem. We can start off by converting the nums array into a set. So we can just say nums is a set of nums, and this is mutating the input. So this is going to be big O of 1 if we don't include the input. And we can define a result, which is going to be 0, and the result is the longest length of the sequence that we find. And we know at the end we're going to be returning this result. So now we can go ahead and loop over each of the elements in the num set. So we can say for num in nums, we want to check if it defines a sequence. So that means the element before num or num minus 1 is not in the set. So if num minus 1 is not in nums, that means we have a new sequence. So we can set the length equal to 0 for the sequence, and we want to continue until we find a value that is not in the set. So what we can do is we can basically just keep incrementing the length and add it to the number. So we can say num plus length. If this is in the num set, then we want to keep going. So length plus 1. And once this exits the loop, then we want to verify and check if it is the longest or not that we found. So we can just do result is equal to the maximum of what is currently stored versus what we just calculated, so just the length. And this is the entirety of the code. It's quite short and pretty straightforward, so we can go ahead and submit the code and see if it works. Yeah, and as you can see, the code is accepted. So you can see that it runs quite well, and it has a time complexity of big O of n, satisfying the requirement, and it also has a space complexity of big O of 1 or big O of n, depending on how you create the set. So with that being said, hopefully this video helped you and you learned something, and I'll see you soon.